Hello, welcome to the playlist of videos on essential topics on probability for data science. I am Hemakumar Kasala, and in this video, I will introduce you to the basic underlying concepts and the definitions for probability. Under the basic concepts, I'll explain you the very essential underlying concepts, namely chance experiments, sample space, events, simple events, and likelihood, which can be equally likely and not equally likely. Note, without understanding these concepts, one can never claim having understood the probability in completeness. Finally, using the above concepts, I'll introduce you to the two defining statements on probability, one for equally likely and the second one for not equally likely cases. Let's get into the video. Probability and statistics form the fundamentals in data science studies. While statistical methods play the primary role when it comes to collecting, analyzing, and making the inferences on the data, probability theory provides the means to evaluate the reliability on the inferences and conclusions that the statistical methods arrive at. Hence, it is important to understand the essential concepts in probability and statistics in order to understand data science thoroughly. In order to understand probability, one must understand the following fundamental concepts clearly: chance experiments, sample space, events, and simple events. Without understanding the above concepts and their definitions clearly, it is impossible to claim that one has understood probability. These terminologies keep repeating often in probability discussions, and hence one needs to understand each one of them in detail. Chance experiment. A chance experiment is any activity or a situation in which one out of two or more possible outcomes can result, but with an uncertainty on which one of the outcomes will occur in each instance of the chance experiment. A simple example is tossing a coin. There are two possible outcomes, head side up or tail side up, but with an uncertainty on which one of the two sides will occur each time the coin is tossed. Here is a more interesting real-time example for a chance experiment. Let's take the case of a popular store that sells wide range of household items in a locality. Chance experiment in this case is choosing a customer exiting the shop randomly one at a time and noting down the number of items purchased as the outcome for this instance of the chance experiment. The chance experiment may be repeated and repeated a number of times. Each instance of the chance experiment results in an outcome which is any one among the many possible values that is anywhere between 0 and a finite maximum possible number. Each instance of the chance experiment is also called a trial. Sampling is also a chance experiment. Drawing a random sample of objects or individuals out of a population is a chance experiment, wherein each random sample is an outcome for a given instance of the chance experiment, which is sampling in this case. And each outcome or the random sample in this case is any one among the many possible unique or distinct samples out of the population. Sample space. Sample space is a collection of all possible outcomes of the chance experiment. All possible outcomes in the store example is the range of numbers between 0 and maximum number of items ever procured from this store. Each outcome in the sample space is also called as the sample point. Sample space in case of coin toss experiment will have two possible outcomes, which are heads and tails. Number of variables of interest in each outcome can either be a single variable or a multivariable. It is single variable in case of coin toss chance experiment. Variable equals side of the coin and value equals head or tail. Single variable in case of store chance experiment as well. Variable equals number of items purchased and value equals the number of items recorded. Outcome can be multivariable where variables of interest are more than one, as in the following case. Outcome in this case, which is a sample, carries data in multiple attributes or variables, namely gender, income, profession, etc. Sample space is a countable sample space if the total number of possible outcomes are countable. In other words, the total number of possible outcomes are finite. Maximum number of items purchased is a finite number in case of the store's chance experiment. Hence, number of all possible outcomes is also a finite number. And sample space is a countable sample space in this case. Sample space is a continuous sample space if the total number of possible outcomes are not countable. In other words, the total number of possible outcomes are infinite. Imagine instead of the number of items purchased, if the waiting time in the queue is recorded as the outcome, then number of all possible outcomes is an infinite number given a range for the waiting times. And sample space in this case is a continuous sample space. Event. When an outcome of a chance experiment instance equals a single preferred outcome, or when an outcome of a chance experiment instance is one among a set of preferred outcomes, an event is said to have occurred for that instance of the chance experiment. Event example. For example, when the preferred outcome is 5, and if the outcome of a chance experiment instance equals 5, then an event is said to have occurred for this instance of the chance experiment. Similarly, in the case of the chance experiment where the waiting time in the queue is recorded, if the preferred outcomes are waiting times less than 2.5 seconds, and if the outcome of a chance experiment instance is less than 2.5 seconds, then an event is said to have occurred for this instance of the chance experiment. Event definition. When an outcome of a chance experiment instance is one among a set of preferred outcomes, then an event is said to have occurred. On the other hand, when an outcome of a chance experiment instance equals a single preferred outcome, then a simple event is said to have occurred. Simple event is an event where the preferred outcome is just one single outcome. In other words, just one sample point. Event and a simple event comparison. While occurrence of one among many preferred outcomes qualifies an event, occurrence of the single preferred outcome qualifies a simple event. Subset of outcomes that constitute an event can be the result of a set of logical and/or arithmetic operations on the variables that qualify the outcomes. For example, sample contains those whose age is under 10 and/or male can be an event, where age and gender, male in this case, are variables or attributes, and under and or arithmetic and logical operations respectively in qualifying the event. Events can be more complex than being mere subsets of outcomes from the sample space. They can be results of logical combinations of events. For example, A union B or complement of A intersection B or expressions involving even more complex logical operations can also be events. where A and B are events comprising different subsets of the sample space. Probability definition. The definition for a probability depends on the likelihood of occurrences between the outcomes of a given sample space in any given trial. There are two cases: when the likelihood is equally likely and when the likelihood is not equally likely. Likelihood of occurrence for an outcome is in essence the frequency of occurrence of that outcome in the sample space when the chance experiment is repeated over a large number of times, that is, number of trials tends towards infinity. Probability when the likelihood is equally likely. In an equally likely case, the frequency of occurrence remains the same for every unique outcome in the sample space. That is, the frequency of occurrence of 4 items being purchased is the same as for 3 items being purchased, 9 items being purchased, and so on. There is no bias whatsoever between the outcomes in a sample space. Probability when likelihood is not equally likely. In a not equally likely case, the frequency of occurrence is not the same across the outcomes in a sample space. That is, the frequency of occurrence of 4 items being purchased is not the same as for 3 items being purchased or 9 items being purchased or any other number. There is certainly a bias between the outcomes in a sample space. Probability definition for equally likely cases. When the outcomes in the sample space of a chance experiment are equally likely, the probability of an event E, denoted by P of E, is simply the ratio of the number of outcomes favorable to E to the total number of outcomes in the sample space. In other words, probability of E equals number of outcomes that make up an event E divided by number of outcomes in the sample space. Example of an equally likely case. In a chance experiment of rolling a single fair dice, event E being any even number, which in this case is 2, 4 or 6, the probability of event E equals number of outcomes favorable to E divided by number of outcomes in the sample space, which in turn equals number of outcomes in 2, 4 or 6, which equals 3 divided by 6, and hence probability of E equals 3 divided by 6, which equals 0.5. Probability definition for not equally likely cases. When the outcomes in the sample space of a chance experiment are not equally likely, like in the case of the store chance experiment, it is hard to imagine that frequencies of outcomes, which is the number of items purchased, be the same across all outcomes. The probability of an event E, PE, is evaluated using the ratio of number of times the outcomes favorable to E occurs to the total number of trials conducted, where the total number of trials of the chance experiment is a very large number. The above approximation for not equally likely cases converges towards the actual value of the probability as the number of trials become larger and larger. The above definition of probability is based on the relative frequency approach, wherein the probability is measured using the relative frequency of the event as the number of trials tend towards infinity. As one can understand that it is not straightforward to evaluate the probability in case of not equally likely outcomes cases. It involves running a large number of trials and can get quite cumbersome at times. That brings us to the end of the session on this introductory video to the very elementary concepts and definitions that explain probability. Please leave your comments or questions if any, and I'll try to revert back with my response as soon as possible. See you with the next video on playlist of essential concepts on probability. Bye till then.